The death of the query? Why SQL and JSON are the secret architects of the AI era. In the ever-evolving theater of data science, where large language models are the flamboyant lead actors and SQL is the dependable stage manager, a third character has quietly moved from a supporting role to become the director of the entire production, JSON. For those who want to navigate this landscape, it is necessary to understand the interplay between these three, because it is the blueprint for modern AI orchestration. While SQL manages the source of truth, and AI provides the reasoning, JSON serves as the nervous system that connects them, proving that sometimes the most important part of a system isn't how it thinks or where it sleeps, but how it talks. To appreciate JSON's current dominance, we must first look at its surprisingly humble origins. Formalized and popularized by Douglas Crockford in the early 2000s, JSON, JavaScript Object Notation, was originally a hack to get data to move smoothly between servers and web browsers. Before JSON, we lived in the era of XML, a verbose, tag-heavy format that felt like trying to send a simple text message wrapped in 3 layers of bubble wrap and a wooden crate. JSON arrived as the minimalist alternative, a lightweight, text-based format that humans could read and machines could parse in their sleep. In conventional systems, its job was simple: be the postal service for the web, carrying data packets from point A to point B without the overhead. Fast forward 20 years, and JSON has undergone a career pivot that would make any LinkedIn influencer jealous. While it is technically a legacy web technology, it has become the de facto language of AI orchestration. Indeed, tool calling schemas of OpenAI, Anthropic, and Google are all JSON-based. Why? Because LLMs are probabilistic. They are essentially vibe-based calculators, which are probabilistic sequence models trained to predict token distributions. However, if LLMs have mastered the art of human conversation, why are we still forcing them to speak in the rigid, bracketed language of an old web format? The answer lies in the fundamental tension between human intuition and machine precision. If you ask an LLM for a list of names in plain text, it might give you a bulleted list, a comma-separated string, or a poetic haiku. For a computer program or a SQL database, this inconsistency is a nightmare. JSON provides the contract or the guardrails that force these chatty models to speak in a predictable, structured format. This brings us to the most critical advancement in AI integration: function calling. Think of the LLM as a brilliant but locked-away brain that has no arms or legs. It can think, but it can't do. Function calling is the bridge. When you tell an AI, find the average salary of professors in the data science department, the model doesn't just guess. It identifies that it needs a tool, a SQL query. It then generates a JSON object containing the specific parameters needed for that query. Your application takes that JSON, executes the SQL, and sends the result back to the AI in, you guessed it, more JSON. In this dance, JSON is the universal translator between the fluid natural language of humans and the rigid mathematical certainty of SQL. Beyond real-time talking, JSON is also how we teach AI to get smarter. When researchers fine-tune models to understand specific domains, like your university's academic policies, they don't just dump PDFs into a folder. They use JSON-L, JSON lines, the industry standard for fine-tuning datasets. Each line is a standalone JSON object containing a prompt and its ideal response. It's like a digital flashcard. This format allows engineers to stream massive amounts of data into training pipelines efficiently, ensuring the model learns the exact nuances of the data it will eventually be querying via SQL. As we move toward an era of agentic AI, where models don't just answer questions but take actions on our behalf, we must ask ourselves, if JSON has become the universal language that bridges human intuition and machine logic, are we moving toward a future where coding is less about syntax and more about defining the perfect JSON schema? I'd love to hear your thoughts on this. If you found this breakdown helpful for your studies, please comment with your take on the future of data formats. And don't forget to subscribe, like, and share this with your cohort. After all, in the world of AI, the better our connections, the smarter our systems.